Hello everyone. Today I'm going to talk about Middle Ages in Europe. The timeline, it goes from 473 to 1453. Their economy was based on agriculture, feudalism, and relations were bachelors. In their society, there were great inequalities. The majority of the population lived in poverty. There were continual wars. It was ethnocentric and stately society. There was close groups. The most important historical events were the Crusades, the Western Schism of the Church, the spread of the plague, and finally the birth of the bourgeoisie at the end of the Middle Ages.
Until that time was known the geometry of Greeks, algebra, the system of decimal, and the zero of the Hindus, generalized by the Arabs. The numbers were natural, rational, irrational, all positive. The negatives were
Let's see
false
the
or
main
false.
advances of the Middle Ages. First, we have the Fibonacci succession. It's an infinity mathematical succession. It consists of a series of natural numbers that add up to 2 starting with 0 and 1. Basically, the Fibonacci sequence is done by always adding the last two numbers, like 0, 1, 1, 2, 3, 5, 8. Fibonacci, also known as Leonardo of Pisa, was an Italian mathematician. Fibonacci was the son of a merchant and grew up traveling in a medium where the mathematics were too important, arousing his interest in the calculation immediately. Clear examples in which the succession of Fibonacci is fulfilled are the arrangements of the branches of the trees, the seeds of the flowers, the leaves of a stem. Other more complex and even more surprising is that it is also fulfilled in hurricanes and even in whole galaxies, from where we get the idea of the Fibonacci spiral. Also, some melodies follow this succession. Thanks to this, the music take rhythm and make them harmonious. Another example in music are the case of piano that are grouped in series of 2 and 3, and we find groups of 5 black keys for every 8 white keys. In art, compositions such as Vitruvian Man or Leonardo da Vinci Gioconda also fulfill the proposition of this succession.
Another advance was the mathematical power concept. Nicolas Hermes generalized the concept of power, introduced the fractional exponents, the rules of conducting operations with them, and special symbology. Also, he made an advance to the idea of logarithm. Nicolas Hermes was born in 1325 and he died in 1382. He was a French mathematician and astronomer. He also studied theology in Paris. The repercussion of his advance was that it was a way to streamline certain mathematical processes as well as multiplication with addition. The powers are more abbreviated and a quick way to express a group of multiplication of the same number. Currently, powers are an abbreviated way of writing a multiplications formed by several equal numbers. They are very useful to simplify multiplications where the same number is repeated.
Another advance is the book Arithmetic, written by Al-Jurismi, one of the best-known Arabic mathematicians in history. In his book, he explains the operation of the decimal system and the number 0 used in India. Al-Jurismi was a mathematician, astronomer, and geographer of Persian origin, considered the father of algebra. Not much is known of his life, but he lived near the early 9th century and worked in the library of Caliphs of Baghdad. It had a great relevance because it contributed to the diffusion of the Indian numbering system and to the knowledge of zero. and it also made known to the world the positional notation, that it's a numeric writing mode in which digit has a different value that depends on its relative position. For example, in our decimal system, when the largest number of the unit column is represented, which is 9, if we want to represent 10, we will have to add a new column. To start with the minimum value of the representation, 1, in the 10 column. In addition, the 0 value is added to the column of the units. Currently, the Indian numeric is still used in India, Pakistan, Bangladesh, Nepal, and Burma, although in many other places in the world the decimal numbering system is used, which is based on the same
Let's see
principle.
now to finish the last advances. Abu al-Wafa Budhani was born on June 10 of 1940 in Budwan, Nizapur, Iran, and died on July 1 of 998 in Baghdad, Iraq. He was a Persian mathematician and astronomer, most notably in the latter, especially in the field of the plane and spherical trigonometry. He introduced the tangent function, that is, the relation between the opposite and adjacent legs, the secant function, that is the inverse of the cosine, and the cosecant function, that is the inverse of the sine. He devised a new method of calculating the shape of the sine, with an accuracy of 8 decimal places, establishes trigonometric identities, and he also proposed the definition of the trigonometric functions of the unit circumference, that is, a circumference of radius 1 and with a center in 0, 0. Also, he discovered and proved the sine theorem for spherical trigonometry, that is, the one that studies the polygons that form on the surface of the sphere, especially triangles. The definitions of the trigonometric ratios of the unit circumference are very used for the explanation and introduction of new students in this subject to the basic concepts. The trigonometric identities established by the allows great facility when solving problems and trigonometric equations involved in fields such as topography or architecture. The tangent, cosecant, or secant functions are also fundamental in trigonometry, that they are used daily in the architectural or topography study. The sine theorem applied to spherical trigonometry allows the study of the terrestrial surface, allowing the development of marine navigation routes, geographical location, etc. Thanks for listening our podcast. See you soon. Bye.